All right, so my name is Eric Davis. I'm a University of California, Los Alamos National Lab postdoc entrepreneur fellow. I work in the material synthesis and integrated devices group at LANL. And my technology is called SoniView, and it allows you to see the unseen in your production process. So our basic value proposition is that we aim to save breweries time and money through smarter fermentation and slurry dump automation. Yes, we will be talking about beer, so I know everyone loves that. So the problems that we're specifically targeting is that there's significant beer loss during fermentation and during what is called a slurry dump process at breweries. And this is a process that is pretty much at almost all scales, especially at the craft breweries and even up to the huge multinationals. This is all kind of a problem that's endemic in the industry. And after doing a lot of customer interviews, we found that basically the brewmasters know that they lose the most beer during the fermentation. And so that's the part that needs to be targeted through technology. They found that measuring fermentation progress in real time is extremely beneficial, as nearly everything is manual at this point. So as you can see in the picture above, the guy is taking a manual specific gravity sample of beer during the fermentation. And they do this roughly every 6 hours for several days. And basically, when they're trying to determine the end of their fermentation, at worst, they can be around 2 days off of the true end of fermentation. So not only is that a lot of manual labor of having someone constantly take samples, but also you're significantly off of the true time and you're fermenting longer than you need to by doing this manually. And then finally, when you're done with fermentation, you have a lot of spent yeast at the bottom of your fermentation tank that is generally just dumped out of a valve at the bottom. So what they've said is that everyone judges when to stop draining this valve by sight. So how much beer I lose depends on who is working that day. And so first the yeast slurry comes out, and this process can take anywhere from 30 seconds to 30 minutes. And then eventually the beer starts flowing. And if you do it too long, then you start to lose a significant amount of product. Now imagine if you multiply this out throughout a whole year, not having this automated and having some guy having to sit there and do it. That's both a significant waste of labor as well as you're really playing with fire in terms of losing beer when you could have been automating this the entire time. So our solution is to basically take our acoustic technology and basically automate these processes as well as monitor them automatically and provide this information to the brewmasters. So we're taking this acoustic technology that was originally developed for both DoD applications as well as oil and gas, and we are adapting it to operate on conical fermentation tanks, which is the most common fermentation tank used in the industry. We will provide real-time monitoring of key fermentation parameters that basically inform the brewmaster of how his fermentation is going and when it is about to end. We want to automate the slurry dumps for minimal product loss so that basically it's a push button operation and it always gets done perfectly every time. And we want to provide data-driven insights to these brewmasters so that they have additional data to judge the performance of their fermentation and to make better beer and to lose less of it. So the technology, I'll just go through this a bit. So it is what's called an acoustic multi-phase flow sensor. What it means is that it uses acoustics to basically monitor many different phases going through either a sealed container or a flow pipe, and it gives you that information. So basically, we are engineering a specific acoustic pulse to transmit through either your sealed container or your process pipe. And then it is going to give you some information back, which through signal processing, we can tell you both the health of the pipe that it is on, as well as what the composition of what's inside the pipe is, and also the flow rate of what's going in. And so you can see basically what is flowing through there and how much is flowing through there. And this is all done through simple electronics and signal processing. So it's a relatively mature technology at this point. And so basically, we want to end the fermentation and slurry processes precisely when they are finished and not basically doing it all by hand. That will allow us to increase the turnaround time, allowing up and coming craft breweries to get more batches out of the same amount of capital equipment so that they can scale without having to buy new equipment. And we're hoping to get about 25% more batches in the same amount of equipment. We want to remove the speculation of when the batch is finished so that you don't spend a lot of money on pumps and machinery running when the thing has been finished this whole time. We want to save beer, allowing them to maximize their output through their input resources, and of course, increase these breweries' profit and bottom lines. So the market opportunity, basically a lot of common size fermenters, price range somewhere between, the few thousands of dollars. Of course, with the gigantic tanks, that's going to be much larger, but it's roughly depending on the size of the brewery. The global market for new tanks is around 1.7 billion per year. We estimate that there's over 40,000 fermentation tanks in the existing 4,500 U.S. craft breweries nationwide. These numbers are only looking at the U.S. So we calculate a service attainable market of about 400 million, and that's before you get into recurring revenue models, as well as the other add-on applications that come in after this. And just to give you a perspective, there are competitors in fermentation monitoring, but not in the other application. And the price point of existing competitors are at a minimum of about $10,000 per tank, which is not really that palatable for a lot of breweries. And the applications are much larger than that, a lot more money. So looking at a competitive landscape, basically our SoniView technology compared to maybe a couple of other competitors, as well as manual sampling, which is what most breweries use. Ours is completely non-invasive, so it's not going to mess up any of your operations. Our product cost is the only one that's relatively low, because instead of using optical techniques that are very expensive or other techniques, we're using acoustical techniques, which has much lower cost of ownership, as well as the raw materials are much lower. The ease of installation, this is what's called a clamp-on device. It goes on the outside. It couldn't be easier, and it's ready to go basically without affecting any of the operations that are going on. It's very low maintenance, so you're not going to have to constantly clean this. You don't have to worry about recalibrating lasers or anything like that. So it basically just keeps running for as long as you need it. And it's the only technology other than just doing it by hand that provides both the fermentation and the slurry monitoring. And there's a possibility to do both in one device, actually. So the business model, we basically plan on selling the fermentation slurry monitoring devices directly to breweries, working with the individual breweries to make sure that it fits their tanks, that it's working with what they need them to do. We would be looking at adding advanced data analytics subscription packages. You could be looking at maybe processing some of the data on a cloud, getting data aggregation, selling the performance of different yeast strains and different batches, maybe to breweries as additional data, as well as providing very advanced physics data to a brewmaster who's really interested in knowing very in depth what their batches are doing. And then, of course, there's going to be a lot of add-on products that go off of these initial products that are going to target contaminants and distilleries. We're also going to be looking at wineries and soft drinks, and these are basically applications that are very easy to branch off of what we already have once we break into breweries. So our go-to-market, we expect to have a bench prototype demo. September 2021 is the latest. We expect to have it ideally much sooner than that. So that's coming along right now. A field prototype by the end of this year. We would be looking at licensing to a partner, working with another commercialization company by basically January of next year. Then doing field trials in about March of 2022. And then we would like to see early product sales by fall of 2022. And in terms of licensing with a partner, that doesn't mean that our part ends. Los Alamos has many different programs to work with these companies to commercialize as well as develop the technology to what they need. And so the base technology is what's called a TRL7. It's extremely mature because it's been adapted to, it's been in another application. The application specific TRL is about a 3, but that's going to rise very rapidly with development because this technology already works very well. And we have significant existing IP, and we expect to have a lot of new IP on this application. So our ask is basically, we're looking for a few good entrepreneurs to help us in further our customer discovery with breweries, distilleries, wineries, and soft drinks. We want to know both how we're going to fit into the market in terms of breweries, as well as what our opportunities for wineries and soft drinks are. Assess our financial projections and business opportunities to make sure that our numbers are good, to make sure that we're really broadcasting this opportunity very well, and to further develop the products through a license and programs like NMSBA, the New Mexico Small Business Association program, as well as something like Trigger, which allows us to help a company commercialize this and develop the technology and get it out into the market. Thank you.
Yeah, thanks, Eric. Sounds great. Questions from our sharks?
So Eric, what do you think needs to be modified or enhanced for this technology to work well with wineries and drinks? Like, what changes need to happen?
Right. So not a ton of changes need to happen with the actual technology. It's just that we need to have a good understanding of the problem. And then basically we would be adapting the technology to their problem. So there's not a lot in terms, the base technology doesn't change. We already have a lot of software, hardware to be able to do it. It's just that we would have to adapt the technology to the specific tanks or containers that they have, as well as making sure that we can track whatever they want us to track with our technology.
And in terms of applying to beer, and do you think the container size matters or the flow rates matter when it's coming out?
Right. So so the flow rate doesn't really matter that much because this technology works with a static container that has no flow, and it works with things that have relatively high flow. So the flow rate isn't really something that matters. Container size, we've done all the way from the very tiniest containers to relatively large pipes. Obviously, we can't adapt this technology to a really huge, massive tank. But in general, these types of equipment, industrial tanks, always have some sort of point to where you can mount it. And even then, there can always be an auxiliary port. You can always put it at the very bottom where the actual valve is to dump the yeast slurry is. There's a lot of possibilities, basically.
So in terms of placement, then do you intend to do multiple of these sensors in one if you have a large container?
Right. So we will only need one set of sensors. It's just that part of the field trials, what that would be working on is figuring out the best place to put it. That's basically what the field trials are for, is finding what is the most effective place to put it inside an actual brewery, and how common is that throughout all the breweries, because we really want to find a mounting point that's the most common throughout all. That's not really a big engineering or technical challenge. That's just something that we need to learn by working with local breweries.
But then if there are multiple equipment suppliers, if there are multiple, change the placement too, right? Depending upon whose tanks are they using.
So there are a lot of equipment suppliers, but the general shape of the fermentation tank is roughly the same. And so despite the fact, they may have different thicknesses, which means you would have to have slightly different calibration. But in general, the general shape is about the same. And there's only so many things that you can do to a conical fermentation tank. So we imagine that if it works really on one, it's going to work on all of them.
Okay, thank you.